In June 2020, world news agencies spread the news that China had completed the construction of the main pillar of the Jinyanghe Bridge, 196 meters high, which became the highest pillar of the world's tallest frame bridge. A year and a half later, the entire project is being prepared for the final stage and commissioning. China once again decided to surprise the world and did something no one had done before. The Jinyanghe River Bridge is a key transportation project and an important battlefield for China to reduce poverty in the country and develop depressed regions through infrastructure development. Jinyanghe County is one of the 7 poorer counties in Sichuan province. Because of its difficult terrain and many geological disasters, it has a complicated history. The devastating earthquake in Sichuan occurred in 2008, killing at least 69,000 people. At that time, 374,000 people were injured, 18,000 were missing. More than 45.5 million from 10 surrounding provinces and districts were in the zone of strong shocks. About 15 million people fled their homes, and more than 5 million were left homeless. About 5 million homes were destroyed, and more than 21 million homes were damaged in Sichuan and neighboring provinces. At that time, economic losses exceeded $150 billion. The earthquake in the old Jinyanghe County caused severe damage, after which a new area was built, more suitable for life and development. The old and new county areas remained separated by a river and a gorge. However, due to the lack of a direct river crossing, the road takes longer, significantly affecting the economy of the region. The bridge is a long-awaited salvation for the entire province. After almost 4 years of preliminary exploration and approval, in November 2017, the construction of the bridge began. The total investment in the bridge is $50 million. The bridge is about 1 kilometer long. It uses a prestressed monolithic box beam and a continuous rigid frame span. The bridge was designed right across the river valley. It has 9 piers and a height of 200 meters. The main piers, number 5, number 6, and number 7, are hollow piers of high-strength tubular steel concrete. The main bridge pier number 6 is 196 meters high, and the total height of the steel tubes is 207.7 meters, which corresponds to the height of a 70-story building. Thus, bridge pier number 6 ranks first in the world in terms of height among similar rigid frame bridge piers. According to the construction company, the biggest challenge in building the bridge is the strong winds in the valley and the long rainy season. Special self-climbing equipment was used to build the piers. It not only ensured the safety of people working at high altitudes, but also reduced the construction time by at least 3 months. The main pier of the bridge is in the form of a hollow shaft made of steel lattice tubes filled with concrete with high seismic performance and high economic efficiency. This type of abutment was previously designed and built only on the Libajian Bridge on the Yangtze Expressway in China. Thus, the Chinese engineers did not have much experience and full practical data that would simplify the design and construction of a bridge of such height. During the design and construction of the bridge, new technologies have been mastered, such as the construction of a continuous ultra-high pier, the structure of the steel base of the bridge, the high-altitude lifting of steel pipes weighing more than 40 tons, and the ultra-high and ultra-long high-performance concrete pumping. The ultra-high tower crane and elevator system with operational safety assurance were developed. All this was created from scratch by Chinese engineers for the project of the highest frame bridge in the world. In the process of urbanization and project diversification, Chengdu Institute has designed and built more than 600 bridges of various types, including world-class high-pillar solid steel bridges, rigid frame arch bridges, steel tower, cable-stayed bridges, and long-span suspensions. However, the construction of the Jinyanghe Bridge was a new milestone and allowed for the mastery of even higher construction technology for ultra-complex engineering projects. The final part of the Jinyanghe River Bridge construction is a key process with high technical complexity and high safety risks. The process not only of construction but also of operation has high precision and strict requirements for ambient temperature. Due to the high altitude, the bridge must be closed when the air temperature drops to low levels. When completed, the bridge will become the main crossing, connecting the old and new urban areas of Jinyanghe County, as well as a vital evacuation corridor in case of geological disasters in the old districts of the county. It will greatly simplify connections across the gorge and the river, further activating the development potential of the new urban Jinyanghe County. Travel time will be reduced from more than 1 hour to less than 10 minutes, bringing comfort and convenience to more than 120,000 people. The Chinese know how to build not only bridges. Chinese builders and engineers possess skills that engineers from around the world can envy. The Chinese government loves large projects that allow officials to kill 2 birds with 1 stone, meet the needs of the country's huge population, and once again show off their technical achievements. The height at which Chinese installers work is the equivalent of a 90-story building. But the workers building the country's new power grid don't seem to have time to worry about such trifles, because they are busy building the tallest pylons in the world. In East China's Zhejiang province, an unprecedented construction of the world's tallest electric line, Jinyanghe, has been completed. The line that will connect the Jinyanghe archipelago with the mainland includes a unique crossing over the sea between the Jinting and Sezi Islands, based on two 380-meter poles of Chinese design, the highest in the world. The design of this transmission line ensures the connection of the banks without intermediate supports. This line is only part of a global electrification project for all of China. The total length of this line will be 3,324 kilometers. The voltage on the ultra-high voltage transmission line is 1100 kilovolts, so the system is mounted. The construction of power transmission towers is part of a large project to create an ultra-high voltage transmission line between two urban districts of China, Jiaoshan and Ningbo. China recently launched an ultra-high voltage DC power line, which broke the world record for voltage, power, and stretch. The operating voltage of the new State Grid Corporation of China line is 1.1 megavolt. It can transmit up to 12 gigawatts of power and up to power 50 million homes. Although the transformers installed in the substations are considered mobile, it is difficult to call them mobile, since each one weighs 800 tons. The engineers who worked on the project call the line the Power Silk Road, because it follows the ancient trade route of the same name. The line absorbs AC from the grid at a converter station near the capital of Xinjiang and sends DC power to a second converter station in East China's Anhui province. It will transmit energy, replacing 25,000 trains with coal, needed by thermal power plants. The designers wanted to install fewer large transformers to achieve maximum cost effectiveness, but for a 1.2 megawatt converter plant, these cannot be delivered from factories. They worked on the project for more than 10 years. It involved major contractors such as Sweden's ABB, which plans to create a fully automated factory of the future in the Celestial Empire, and Germany's Siemens, which recently launched the world's first 10-megawatt wind turbine with a 193-meter propeller. Currently, China is actively engaged in the development of such projects. The fact is that the main energy resources of the country are remote from the outskirts of the state, which entails a number of serious problems, one of which is the difficulty in organizing a reliable power grid, which consists in significant energy losses during transmission over long distances. Carbon-free transmission lines will also help Chinese energy companies achieve two main goals: increase consumption of green energy, reduce downtime of alternative generating stations. The massive use of ultra-high voltage lines will attract about $30 billion in investments and will create over 10,000 additional jobs in the field of renewable energy and related areas. Long-distance power lines are also included in the strategy to stimulate the Chinese economy, which showed negative dynamics against the backdrop of the coronavirus pandemic. The construction of the line will help to expand the idea of what an ultra-high voltage transmission line with such a long length is. The transmission line will play a key role in integrating renewable energy sources remote from consumers into the national power grid. China has large load centers in the eastern region of the country, while a significant amount of energy resources are located in the west and northwest. The increase in demand for electricity over the past decade has prompted the development of ultra-high transmission lines to transmit power over long distances with minimal losses. Write in the comments which of today's Chinese mega projects impressed you. If you enjoyed the video, don't forget to like it and subscribe to the Karo Show channel. Also watch our previous videos. Goodbye.